Hello everyone, my name is Pavel Perfilov and today I'm going to talk about the practical usage of microservices in investment banks or brokerage companies. Let me start with the introduction. I work in Fintech for about 15 years and 8 years I was doing development and I was managing the IT landscape in one of the emerging markets brokers, which had offices in South Africa, Cyprus, Turkey, US and London. I was managing multiple teams and worked in front office, back office, and risk management. I worked as a business analyst, developer, and project manager. For quite a long of time, I was a member of technical committee in some of the exchanges. And small disclaimer here, I am speaking as myself and not as representative of any of my employers. Okay, let's get started. Yeah, what is the motivation of this talk? I wanted to share my experience, which I've got when I worked at the brokerage company and as a consultant. And yeah, let's begin. You all probably know digital banks, and you have heard about the Bank N26, Revolut, DeGiro, and others. And have you ever thought about like why the classical banks and well-established banks are not having such a good mobile application? No? Let's discuss this. Today we'll have an overview of the typical brokerage infrastructure to get some understanding of about the context. I'll explain you how the IT architecture look like, and we'll walk through the challenges of the classical bank and why and how these banks are chased by the digital banks. And finally, we should come to the conclusion where and why microservices are fitting good and where they don't fit good. Let's start with the simple block diagram, which describes the skeleton of the broker. There are six main functions of the classical brokerage house. We'll not dive into the IPO financing, and we'll just focus on the brokerage services. So it's quite straightforward. Here's the client who sends the request. The request is picked up by the client services and forwarded to front office. Front office processes the instruction and makes the risk check and makes the trade, and then passes the trade to the mid office. Mid office books the trade, adjusts the account balance, calculates fees and other portfolio metrics, reported to the exchange, and passed to the back office. Back office enriches the trades by applying the trading schema, which might be complicated sometimes. It adds reference data, market value, adjusts the depot account, and so on. In 1 or 2 days, the trade is settled, meaning that the bank has sent money and we've got the security, or vice versa. We send the security and get the money. There might be a treasury department, which function is a maximization of the efficiency of the capital usage. It helps with the borrowing and lending money of securities. There are a few other departments which are taking care of that the processes are well established and which are compliance, regulatory reporting, IT security, and IT audit. These departments are making sure that there are no bad practices and the quality of the process is good enough. So basically, it looked like a car factory or conveyor. But and not much of these processes are being done in parallel. So the process is very sequential, linear, and straightforward. In early days, people were printing tickets and were passing them from one department to another, literally a piece of paper. Nowadays, these tickets are just records in the databases. There are a few more departments who make products and services are more attractive, more secure and beneficial for the client, like a risk management, because client usually tends to borrow the money or keep money in the bonds, and sometimes they require or like the financing or payments. So basically, they want to all the services be packed in one application or in one in one window to serve all of their needs. Corporate actions are making sure that you would not miss the corporate action and get the dividends, or you would need to vote for if you have some certain stocks and which have like necessary permissions. You might have or you might want to have the plastic card with the saving accounts, which automatically allocates money to securities or currencies. And that is literally it. We just described the company with a size of 500 to 1,000 people. So it's literally like that. These are the departments of the bank. So now you know the context, and you might wonder how the IT architecture looking like. We're all in a technical conference now, so it makes sense that you would ask this question, why I'm telling you this economical story. Yeah, don't be surprised how simple is it. Here's the line which represents the enterprise bus, like Kafka or TIBCO or Rabbit MQ or any other. Each block now represents the monolith system of every department. Every system is doing something with the client's request or the order. These systems are literally monoliths, and they're different. And this the software stack is different usually. Typically, most of the systems are third party. The client services are typically the web-based application. It's basically like a CRM or like which have like some key KYC functionality and some finance specific stuff. Front office is typically Java or C++ systems with which communicate to the exchanges, doing risk checks and route the orders. Mid office, typically Python or Java. It's with the event triggered logic to process the requests. So it's like a request response, usually some enrichment like to calculate a fee or something like that. Back office typically a huge Java application or the platform where there's a lot of business logic lives, and business logic usually is split between the database and the application. So typically the databases are also like a big, very big monsters. Like it might be like an Oracle or DB2 or IBM Informix or Postgres is very rare, but sometimes it happens. And yeah, the settlement is typically like an integration tool, which is like a scheduler to release the cache or send the Swift messages. And yeah, the most interesting part here is that these applications or systems are not standalone. They do have a lot of integrations to external services, which are necessary to have. And in general, the exposure to external services is very, very high in financial institutions. So let's add them. Here we are. Here are the main components, main external services, which are exchanges, counterparties, brokers, market surveillance tools, OTC reporting, KYC helpers, banks, clearing organization, and so on, so on and so forth. So you see that there's a lot of them, and the environment is quite full of different sort of services. So now you know for sure what these 500 to 1,000 people are doing. So basically, they do care about the system and every system and quality, and they making sure that the systems are reliably working, and they able to settle the few hundreds of thousands of trades daily or few millions of trades. It depends on the environment news and the amount of clients that the brokerage company has. If the bank has the offices in different regions, which is the case for the well-established bank, the global architecture look like this. So architecture is different in every region and has a local specific because of the own exchanges, own regulation, own financial markets, and so on. And the same systems cannot be used and reused because of nature and the environment is different. So small example here is that if you want to make a trade somewhere in, for example, in Singapore, if you're sitting in Amsterdam, in your local bank, so your local bank would route it to Singapore branch. Both banks would have a record and process the trade. So basically here and there, and they would be passing through this like through the whole pipeline twice. And this happens every single time when you tap the button in your application. So in a mobile application, if you tap the button to buy or sell a stock, these processes are happening, and it happens in millisecond time scale to route the order towards the exchange. And during the next 1 or 2 days, the whole process of trade processing and settlement would happen. It's quite complex, right? Yeah, let's look into the IT architecture finally, as long as you know the context. So here's the difference between the digital banks and the software, digital banks and the regular banks, the well-established banks. So digital banks are literally are software houses. So like an Uber or Lyft or any other FAANG companies, and the whole product is designed and is made, like the whole concept of the product is the product is a mobile app which has built-in brokerage services, banking services, and so on. And yeah, the difference is quite significant between in the IT landscape. So the digital banks tend to use open source cloud very intensively. They do have a distributed data model, and inter-domain communication is communications are being made via the API calls, like a request response. The regular brokerage companies or regular banks are to tend not to trust the open source, and they're trying to avoid the cloud infrastructure. It is a little bit changing now, but in general, there is no trust to any services in the internet. They do have own schedulers. They basically the back office system is looking like a one big isolated cluster with a bunch of services which are incorporated in this back office system. And it has own scheduler or event based system and so on. So it's like Apache Airflow, if you would think of, but it's with very high isolation, and it's more reliable and more capable and functionally rich. The data is very centralized in the like regular bank, and the processing is either event based, but it's more in front office, and back office is typically the batch based or like the processing by the timer. Yeah, and the systems are in a classical bank are designed to be self-sufficient, reliable, and they are quite functionally rich. What else we could see in the digital banks? In digital banks are the microservices. Microservices are and containers, because these systems, these companies were created to write software. So they have very cool CI/CD model, very well-designed packaging and deployment. Typically, every microservice has at least 3 layers: authentication, service application, and data layer. Every department has own environment because data flow density is not that high, and it's higher within the department. And this rounded cloud of the dots represents the pods services which owned by different departments. So the color means the ownership of the some certain department. Now think about how the regular bank could go and make this transformation. Is it a really easy thing to change the monolith components into the microservices? And moreover, the kind of the domain the domain is not really fit well in microservices, because not always we do have this concept of request response. So yeah, in moreover, you if you would look at in the internet and search for the incidents, the the microservices sometimes, well, and frequently, are not very reliable, and they cause a lot of issues in these digital banks. So if you would search on the internet, you would find quite an interesting incidents and quite interesting reports because the banks are licensed and they have to report their issues, be it IT issues or business issues. Yeah, so here we came to the problematic of the big banks. So yeah, sometimes that this idea happens that is being brought by the salespeople, and yeah, the big banks are being chased by the digital banks. So they sometimes they launch the project and they start building the mobile application. Yeah, as we discussed, the digital transformation is great in general to have. It improves the software development lifecycle, develops the speed of the release cycle. On the other hand, it could potentially ruin the trust of the bank, which the bank was collecting the like during the I don't know multiple years or decades. So it was collecting by the ages, and yeah, the typical start of the transformation is towards the transformation towards the microservices. It's the idea to have the mobile application and start offering the digital service. And here where the journey begins. Okay, let's now think, play the game, play a little bit of role. Let's imagine that we're a classical bank and we decided that we're brave enough and we could step into the containers world and the microservices territory, and we would need to have yeah, what do we need to have? We need to have the technical stack is completely new. It has containers, REST API, API gateway, some authentication gateway, CI/CD tools, packaging, logging, and some extra hardware. Typically, digital companies are having some overhead uh, and uh, and some extra demand for the hardware to build their cloud or internal cloud. What else do we need? We need people. We need skilled people like DevOps, SecOps, cloud engineers, and developers. It's not really a lot for the big bank. I think it's more or less affordable. Probably all of these technical requirements and people requirements are kind of could be satisfied with a couple of million of dollars a year. Um, yeah. How would you think that the first trading application would look like if we would satisfy all of these needs and we would get all the people and build a tech stack? Yeah, that's easy. That would look like a big copy machine. So mobile team would make own environment, own Angel, and would start deploying the tens of hundreds of services. It would be very, very suboptimal. And the reason is that typically monolith systems are having a lot of specific and the system, the third-party systems are having a usually interesting API. And the easiest way to sort out the integration problems is to stream the all data into the own environment. So literally copy the data which every system has into the own environment, normalize the data and start using it. So there's nothing bad in this approach, but in general, it would not increase the speed of development. It would make the life more complicated because of high amount of dependencies. It would not be improving the security. In general, it's not secure approach at all because the more data is flying and the more data flows the company would and the bus would have. Yeah, and performance would be completely suboptimal because of the amount of data and load of and the copy amount of data which has to be copied is huge usually, and it would be very, very expensive. So then the plan probably is not fully correct, and how we could fix that. Yeah, one thing that we have missed, which is for sure would help us, is the inspiration and the open mind at very high level. So one of the big differences of the digital bank is that environment is open, is more open in companies which were created to build the mobile apps. So the environment itself is more collaborative and it uses a lot of open source. Typically, the projects are if they don't contain like some private data or like if there's no Chinese walls, the projects are open for contribution to almost everyone, and people are tend to discuss like cool features, and they tend to grab the some pieces of functionality from one project to another. In the regular bank, however, the environment is the opposite. It's very closed and it's very defensive. Here is the one of the examples which I have seen in my career when I was doing the some consultancy with regards to like building the mobile app a few years back. The story was the same. There was a monolith system and company decided to build own application. And after hiring the developers and building the environment, they developed a bunch of microservices and they kind of created this distributed architecture. This picture describes only services which were developed because of the mobile trading app. So in total, they have built and deployed 4 different new databases in microservices because they had to replicate the data from the monolith system. They've built multiple logging systems and telemetry because why not? It's container. It's quite easy to deploy new stuff. But it was far away from being from being good because of the if there would be a load a high load, all the external connections would become to be a bottleneck. Uh, yeah, okay. Now we have we do know the problems, and let's sum them up. Here's a matrix of where it's, in my opinion, it's easy to deploy microservices and where they fit well, and where they do not really fit well. And there's a philosophy of the agile development and CI/CD and containers. It's really good thing. It does fit well to the microservices environment, but some of the systems are really better not to touch and better not to they copy the data. It's better to like think about how we could build a proper API in the existing back office monolith system. And yeah, here are the colored services. I've colored the services which are perfect in a perfect spot or a perfect fit for the microservices. Most of them are not really the core services, and most of the time they don't have a high throughput and high uptime requirements. Uh, and in fact, the uptime and reliability are the main factors here because we don't want, and bank doesn't want to lose the trust. Trust is the main core thing of the what the bank has and what is the kind of being a brand or the most attractive thing of the brokerage house. In fact, if the green services would have been dropped into the API, that would already cover 70 to 80% of the logic of the mobile application. That is also interesting, and the interesting fact that I have found during my work as a consultant. So the idea here is that if you are in position that you need to build this mobile app, you don't need to spend resources on building the new environment. But it's better to focus on the bringing the CI/CD and best techniques of the microservices environment, and that would already accelerate and improve the speed of the delivery and the software development cycle. Uh, yeah, let's look at the components which fit very, very well. It's basically the data processing components, enrichment of the reference data. It's web-related services, CDN and data streaming, simulations, and getters, outsiders in the back office. But again, the core processing logic in the back office does not fit well at all. In a high load, that would be a bottleneck because the processing and the pipeline is sequential, and that is the problem because it's not stateless, it's stateful. What doesn't fit well, the order routing, the payments, because of the transactional nature. Again, the transactions are stateful. The real-time data, real-time data is an interesting example. There are two reasons. One of these reasons is purely technical. The UDP multicast is not handled very well in the cloud environment, so this is a technical no. And there's one more thing which is coming with the exchange data policies. Exchanges are selling the market data. It's one of their core products and one of the biggest revenue streams. Usually, the real-time data policies are very strict to data distribution. For example, in some of the US exchanges, the exchange is charging per data distribution point. An average charge is like 500 to 2,000 US dollars per month. And now imagine that you wrapped and created a container which distributes the data, and it turned out that you have auto scaling. So now you could imagine what could potentially happen in case if there would be a high load and the pods would be distributed. How you can calculate easily how much money you would need to pay to the exchange. Yeah. Risk management. Risk management is very latency sensitive, so milliseconds matter a lot. Typically, front office hardware is very special and has some specific network cards, and risk systems might have GPU or FPGA accelerators. And again, core back office. If you look at the modern third-party systems, you would see actually like they already look like a microservices. It's like a big container which contains multiple uh, blocks or multiple subblocks with which manage like some modules which manage the tasks, some specific tasks, or like you would see the scheduler or event-based systems as well. And yeah, the the data loss tolerance in back office is like there is zero tolerance, so don't try to reinvent the wheel. So if you work on the such project, if you want to transform the classical business and monolith architecture into the microservices, make sure that you have started with environment creation. So and make sure that you have built the proper CI/CD. You already have versioning, packaging, and good service discovery services. Next thing that you should be doing is to look at your network and the hardware and the monitoring. So the network should be probably flat or flat-ish. So typically the microservices and this Kubernetes environment require flat network. Otherwise, it would be complicated if you have complicated routing logic. Yeah, and before you step into the container territory, make sure that you have IT security operations, because you would need to install a lot of open source software, and at the same time, you don't want to lose the trust. So it's just a recommendation before you started to change the architecture. Make sure that you have IT security operations, IT security ops sitting with you and planning and designing the architecture. One is one of the important things that I have barely seen, but it's very, very powerful, and it's about the performance. Typically, when when there's a lot of microservices, it's quite interesting and not easy sometimes to find the bottleneck and look at the what exactly takes time. That's why the telemetry is so developed in the Kubernetes, and there's a lot of solutions. But there is an easy way how you can uh, simulate and check what could be your bottleneck. So there's a tiny library in Python. You can use SymPy or PyMC if you have more sophisticated distribution-based simulations. So basically, with this snippet of code, I have developed a simulation of multiple departments, which like simulate the microservices of a front office risk management department and the back office. So this library allows you to simulate the performance and make a pipeline. So you literally specify the characteristics, you know it in advance because you can calculate it. You can calculate how much time it takes for your transaction processing service to put the data into the database and get it from the database. You know how much time it takes for DNS resolve, and the processing time is probably static. So roughly you can calculate how many milliseconds or seconds it takes for processing a single transaction over the batch. And then you can describe all of the services that you have, and then you ask Python to simulate this, and it provides you with the statistics for every single, like it can calculate the capacity, throughput, or latency. I have barely seen this, but it's literally very easy to simulate, and I would recommend you before you started to deploy microservices, just try to make some calculations when you're designing the new digital or new environment or transformation. Here's the summary, and yeah, thank you for listening and having me. Again, the trust is hard to gain and easy to lose. If you work in the bank or you consulting any banks and trying to transform the environment, so just be careful, and thank you for listening.